This video takes a deep dive into the shift of rigor. There are three components of rigor in the Louisiana Student Standards for Mathematics: conceptual understanding, procedural skill and fluency, and application. Rigor is like a three-legged stool. If any of the legs are missing or weak, the stool will fall. The standards set high expectations for all three components of rigor in the work of each grade, which is why teachers should target each aspect of rigor with equal intensity over the course of the school year. Rigorous teaching in mathematics does not simply mean increasing the difficulty or complexity of problems. Incorporating rigor into classroom instruction and student learning means exploring at a greater depth the standards and ideas with which students are grappling. Rigor is only achieved when we focus on how we are asking students to make sense of math and develop knowledge. Rigorous instruction moves beyond right answers. Teachers focus on using rich, task, and deliberate questions to promote understanding of math concepts. They make instructional decisions that move students to new mathematical understanding. This is the underpinning for students to replicate strategies and solve problems using similar procedures. In the Louisiana Student Standards for Mathematics, each standard is aligned to one or more component of rigor, meaning that each standard aims to promote student growth in conceptual understanding, procedural skill and fluency, and/or application. Key words and phrases in the standards indicate which components of the rigor the standard is targeting. Conceptual understanding standards often use terms like explain, understand, or recognize. Procedural skill and fluency standards tend to use words like fluently, find, or solve. And application standards typically have phrases like word problems or real-world problems. Keywords and phrases are underlined in each standard in the rigor documents to help clarify the identified component of rigor. The Louisiana Student Standards for Math rigor documents are located on the LDOE's K-12 Math Planning page, and they outline the specific rigor component of each standard. One element of rigor as defined by the standards is conceptual understanding. Conceptual understanding refers to understanding mathematical concepts, operations, and relations. It is more than knowing isolated facts and methods. Students should be able to make sense of why a mathematical idea is important and the kinds of context in which that idea is useful. Conceptual understanding allows students to connect prior knowledge to new ideas and concepts. Here, we'll examine the development of conceptual understanding for grade 5 students experiencing Module 3 of Eureka Math. This particular module develops understanding of 5NFA1, which is a conceptual understanding standard that is focusing on adding and subtracting fractions with unlike denominators by replacing the given fractions with equivalent fractions in a way such as to produce an equivalent sum or difference of fractions with like denominators. The learning begins in lesson 3 with a discussion about adding quantities with different units as the teacher asks a question: what would 1 adult plus 3 adults be? The discussion then leads to adding adults and children, which builds to the understanding that to add units, a commonality must be found. Visual fraction models are used to help students understand the formation of equivalent fractions to add. The closing of the lesson asks students to look for a pattern across a set of problems that were completed, allowing for the teacher to gauge the depth of understanding for students. Lesson 4 begins with a discussion of comparison, extending the thoughts on using consistent units to compare. Students then use the same modeling process to form equivalent fractions so that they can subtract the quantities using visual fraction models and add to fractions greater than 1. It is suggested that the teacher ask, I overheard a student say the answer will be more than 1. Can you explain why you think so? The discussion and suggested discourse continues so that the class is recapping the formation of the model as it relates to creating common units. In lesson 6, students are modeling fractions greater than 1, always connecting to the equation. The model helps students to see two different ways of representing the difference. The discussion in class reinforces the meaning of the like units. During the debrief, students share their methods with peers. It is not necessary that students do the problem multiple ways, but that all approaches are accepted. In lesson 9, students shift to a numerical approach by connecting the models used in earlier lessons to the formation of the equivalent fractions. The model is not shown, but the thinking is present throughout the class discussion. When the lesson is closed, students' conceptual understanding is reinforced by looking for patterns in the mathematics. Students are given the opportunity to notice that often common denominators are the product of two initial denominators. The idea is planted, but that is not presented as something that will always occur. As the models change and the mathematics become more abstract, the materials allow for students to fall back on the visual models when needed. A deeper look at those lessons also demonstrates that the sample dialogue and the teacher questioning support students' opportunities to solidify the connections between the models and the algorithms, meaning that conceptual understanding is not only by incorporating a visual fraction model or manipulatives, but also connecting those ideas more abstractly for students. The next element of rigor we will look at is procedural skill and fluency. Procedural skill and fluency is the ability to apply procedures accurately, efficiently, and flexibly. It requires speed and accuracy in calculation while giving students opportunities to practice basic skills. Students' ability to solve more complex application tasks is dependent on procedural skill and fluency. Here are two examples of fluency practice for students on 5 NFA1, which is also identified as a fluency standard. Task A is purely focused on one method. There is a sample procedure given, and students are asked to apply that procedure. Task B asks students to show their thinking. They're allowed to more flexibly think about the mathematics. So what about sprints? Sprints have an intentional design, are based on allowing students to compete with themselves. And there's a discussion component related to the patterns students see in the mathematics. Those patterns are essential to help students understand and build more fluency. It should also be pointed out that the fluency expectation for every student is the first quadrant of the sprint. Let's revisit the previous example of 5 NFA1. This particular standard is classified as both conceptual understanding and procedural skill and fluency. You can see the connection between the models and the algorithm is made as students move through the module. When students practice at the end of each lesson, they are asked to think about the connections. In earlier lessons, as they practice, materials require them to demonstrate the connection using the model. Here is a sample from lesson 4. This is also evident in lesson 5. As students have had multiple opportunities to build understanding and become quicker and more automatic with the mathematics, the materials provide more open instructions. Like this example from lesson 9, students are directed to make like units and add. The strategy for rewriting the fractions with like units is not set. At this point, teachers can monitor the strategy students are using. Those who are more fluent may be using a more algorithmic approach. It is important to point out that the fluency and the flexibility allowed by the materials develops over time. As we think about what it means for students to be fluent with skills, we should focus on the ability of students to think flexibly and allow time for the efficiency and accuracy to develop. The focus documents for each grade level give specific grade level fluency expectations as they're set by the standards. You can see here that students are not expected to fluently use the division algorithm until the end of 6th grade. Please reference the focus documents for each grade level fluency expectation. Now we will take a look at application. Application, as expected by the standards, provides valuable context for learning and the opportunity to solve problems in a relevant and meaningful way. It is through real-world application that students learn to select an efficient method to find a solution, determine whether the solution makes sense by reasoning, and develop critical thinking skills. 2 problems are listed. Both problems are aligned to 6EEB7, which is to solve real-world and mathematical problems. In the first problem, you can see the distance Sierra walks is represented by an equation. How far did she walk? The second problem gives more context. Sierra walks her dog Pepper twice a day. Her evening walk is 2.5 times as far as her morning walk. At the end of the week, she tells her mom, I walked Pepper for 30 miles. How long is her morning walk? It's important to notice that the first problem, although it seems to have some context, students may not even read the first problem before they see the equation and begin to solve. The context is very thin, and the words are not necessarily important for students to know what to do mathematically. In this case, a scenario does not necessarily indicate an application requirement of the problem. In the second problem, students must really read and digest the text to understand what to do mathematically. Thank you for taking time today to deeply look at the 3 elements of rigor as required by the standards. Again, let me always reference you to the focus documents and to the rigor documents for deeper understanding at your particular grade level. Always remember that it is important to include a balance of rigor in your mathematical instruction and include conceptual understanding, procedural skill and fluency, and application. If you have any questions about the shifts in the standards or how to access any of the documents referred to in this video, please reach out to stem@la.gov.